This is the group safety assignment video. I'm Montana.
I'm Jess.
I'm John.
And we have Egyptian blue.
Our group has the compound calcium copper silicate, better known as Egyptian blue. Its chemical formula is comprised of 1 calcium atom, 1 copper atom, 4 silicon atoms, and 10 oxygen atoms. Other names it goes by are cuprorivate, frit, and Pompeian blue. The atoms it are composed of is calcium, which is an alkali earth metal, copper, a transitional metal, silicon, a semi-metal or metalloid, and oxygen, which is a non-metal. Determining the category in which these elements reside is helpful in determining the overall safety hazard of the compound, which is necessary for the creation of the safety diamond.
A safety diamond rates the overall hazard of a compound or material. Whenever we looked up a safety diamond for calcium copper silicate, one was not available. So we had to look at a material safety data sheet and come up with our own safety diamond. The blue diamond represents health, any health risk or hazard that the material might have. The red represents the fire hazard, if it burns, if you need to watch out for the fumes, and so forth. This is supposed to be a yellow diamond, but apparently the basket doesn't have yellow markers, so it's orange today. But the yellow diamond represents the reactivity of the compound. Is it stable? Is it reactive? Will it explode on you, and so forth. The white represents any specific hazards that might pertain to the compound. So whether it's an oxidizer or an acid or an alkali, anything specific to the compound. In our case, our health hazard, we rated it as a 1, which means it was slight, because it could be moderately toxic due to the copper. If you have prolonged exposure to the copper and you inhale or digest part of it, it could be toxic to your system. But the material safety data sheet did not label it hazardous, as according to the CLP and the GHS. Our fire hazard is a 0, and it's technically labeled as minimal because the product itself will not burn, but you still don't want to inhale the fumes due to the copper. The reactivity is minimal as well because the compound is very stable and it won't react with water, which is very good because we often see that the dry powder is mixed with water to create like a paint or a dye. And then the specific hazard, it is an alkali because it has an alkali base from the calcium. If you'll recall, calcium is labeled as an alkaline earth metal, so that's where we get that alkali specific hazard. And that is the safety diamond.
Some interesting background and general information on Egyptian blue is that it was the first synthetic pigment and it is very stable. It is a varying blue crystalline material and it still has a bright luminescence after millennia. It's most extensively used from the early Egyptian period, which is 2500 BC, until the Roman period, which is 8800. Vitruvius describes in his work De Architectura that it was produced by grinding limes, rich sand, copper, natron, and heating the mixture into small balls in a furnace at 850 to 1000 degrees Celsius. And it was only at the beginning of the 19th century was the interest in manufacturing renewed by Dolly, Russell, and Folk.
The compound of Egyptian blue has many uses. In ancient times, it was used to produce ceramic glaze and also used to paint walls and tombs. In modern times, it is used in telecommunications and in lasers, as well as for biomedical analysis, due to the fact that it has a long luminescence, lifetime, and intense IT emission. The example is that IR photons can deeply penetrate human tissue, and the pigment's emission at 910 nanometers minimizes light absorption by those tissues.